Okay, we're going to do some work today on finding the length of an arc of a sector. Okay, so there's a sector of a circle and the arc is the curved bit, so the arc is this bit here. Now what we're going to have a go at doing today is calculating the length of the arc. Now to do so, there's a couple of things that we need. We need to know the angle in there. We'll call that theta just now, which is a Greek letter that we use for angles. So it's a circle with a horizontal line, and we'll need the radius. Now, if we're thinking about calculating the length of the arc, well, let's think about where that comes from. Well, the arc is just a bit of a circle. So it might be this bit here. So that would be the curved bit from that slice of the circle. So really, it's just taking a slice of a circle and finding the curved bit from it. Now remember that the curved bit, if you go right round the circle, that's the perimeter of the circle, which we call the circumference, and we know that that has got the formula pi times d. So really what we're just looking for then is a bit of pi d. And how big is the bit? Well, it depends on the size of the angle. So let's start with an example 1. Okay, so let's start with this example here, where we've got the sector of a circle and we're looking to find the arc, which is this curved bit here. And I'm going to say that this angle here is 30 degrees and that the radius is 5 centimetres. Okay, so remember that the arc then is just a bit of the circumference of the circle. So I'm going to call this then LOA, length of arc. So the length of the arc is just a bit of the circumference of the circle. So remember that the circumference of the circle is pi times d. Now how big is that bit of the circle? Well, from the full 360 degrees of the circle, that's going right round the point. Well, we've got a slice of the circle which is 30 degrees out of that 360. So then that formula would give me the length of the arc then. So it would be length of arc equals the slice of the circle, which is a 30 degree slice from the full circle, multiplied by the circumference of the full circle. So the full circle would be given by that pi d, but I'm only looking for a 30 degree slice, so 30 degree slice of the circumference of the circle. Okay, so length of arc is equal to the slice, which is 30 out of 360, multiplied by pi, multiplied by the diameter. Now we can see that the radius is given by 5, so to get the diameter I would just double that to get 10, and now I can punch that into the calculator. Now I've thrown all that into the calculator, so it's just 30 out of 360 multiplied by pi multiplied by the diameter, which will be 10, and I'm going to round that to one decimal place, and it's a length, so it's going to be 2.6, so it was 2.61, so to one decimal place that's 2.6 centimetres, final answer. So let's just go over that again. We're finding the length of the arc. The length of the arc is just a bit of the circumference of the full circle. How big is the bit? It's a 30 degree slice. So out of the full circle, 360 degrees, it's a 30 degree slice of the circumference of the circle, which is pi times d. So it's the slice, 30 degrees of pi times d, 30 out of 360 times pi times the diameter, which is 10. Where's that coming from? Well, that's the fact that the radius is 5, so the diameter then would be 10. Put that into the calculator, round it at one decimal place, and that's 2.6 centimetres. Let's try an example 2. Okay, so example 2, this time we've got an angle which is 45 degrees and a radius of 9 centimetres, and we're going to find the length of the arc. So here's the arc. So remember that that is just a bit of the circumference of the circle. Now the circumference of the circle encompasses the 360 degree turn of the circle, but if we just want this bit, then it's just 45 degrees we're looking for. So remember that the circumference of the circle is given by pi times d, but we only want to find the slice of 45 out of the full circle, 360 times that diameter. So the formula then this time is given by length of arc equals 45 over 360 times pi times d. Okay, so 45 out of 360 multiplied by pi multiplied by the diameter. Well, we can see that the radius is given by 9 centimetres, therefore the diameter of the circle would be 18. So let's throw that into the calculator. 45 out of 360 multiplied by pi multiplied by 18. And to one decimal place, that will be 7.1 centimetres. Example 3. Okay, example 3. This time we've got an angle which is 55 degrees, and the radius this time is given by 7.4 metres. So length of arc is equal to a bit of the circumference. The bit is 55 degrees out of the circumference, which is pi times d. Okay, so 55 out of 360 multiplied by pi multiplied by the diameter. Well, if the radius this time is 7.4, then the diameter will be double that, which will be 14.8. And throw that in the calculator. And that will be 7.1 metres this time. Example 4. Okay, example 4. So it's a bigger angle this time. The angle this time is 125 degrees and 3.6 metres for the radius. So same again, length of arc equals, well, the slice is a bigger slice this time, 125 degrees at 360 multiplied by pi multiplied by d. Remember that pi d is the circumference of the circle, and we are looking for a 125 degree slice. So 125 out of 360 multiplied by pi multiplied by the diameter. Well, we can see this time that the radius is given by 3.6. So the diameter will be double that, which is 7.2. Okay, let's throw all that into the calculator. And to one decimal place, that is 7.9 metres. Example 5. Okay, so example 5, just a wee bit different this time. Okay, so I'm told that this angle in here is 20 degrees, and I'm also told that this is 9.1 metres. Now the question is now going to say, calculate the length of the major arc. This is quite important because we now need to understand and find out what does it mean by major arc. Well, if you can see and look closely at the diagram, there's my arc, but in fact there's another arc here. So if you look at the bit of the diagram that looks like Pac-Man, well, there's a bigger arc and there's a smaller arc. So which one would we call the major arc? Well, it turns out that the bigger arc is the one that we call the major arc. So we would call that the minor arc. And we would call the bigger one the major arc. And I'll just colour those in to make sure that we know which is which. There's the minor arc there. And here is the major arc. Now if you look at the minor arc, then that's obviously just a small bit of the circle, it's a small slice, but the major arc is a larger slice. So to find the length of the arc then, it's definitely going to be a slice out of 360 multiplied by the diameter of the circle. Now, we might be tempted at that point to write down 20 for the slice, but in fact 20 is the slice for the smaller bit, the minor arc. The major arc is actually this bit here. Now how are we going to get this bit here? Well, quite easy. That full turn is 360 degrees, so if I want this bit, I just need to take that 20 away. So 360 take away 20 means that the bigger angle there is 340 degrees. And it's that slice of the circle that I'm interested in. Why is that? It's because I'm looking for the major arc. If I was looking for the minor arc, then it would be 20 out of 360. But it's the major arc. Full turn at 360, take 20 away, means that slice there is 340 degrees. So then it's 340 out of 360 multiplied by pi multiplied by the diameter. Well, we can see that the radius is 9.1, so the diameter will be double that, which is 18.2. Let's throw that in the calculator. And that will give me almost 54 bang on, so to one decimal place, 54.0 metres, final answer.